Welcome, Algebra 1 students. We are back and we are in lesson 54, and we are going to talk about the substitution axiom. And the substitution axiom, there's this big, huge, long definition, and I'm going to go ahead and read to you. It says, if two expressions, A and B, are of equal value, A equals B, then A may replace B or B may replace A in any expression without changing the value of the expression. Also, A may replace B or B may replace A in any statement without changing the truth or falsity of the statement. And A may replace B or B may replace A in any equation or inequality without changing the solution set of the equation or the inequality. All of that to say this. We've been using substitution all along. Whenever we would have x, like a x minus 2 equals 4, right? And we sub in and we say, well, x is equal to 6. And we take this value here, we drop it in. We know that's true, right? Because 6 minus 2 is 4. The value of x is equal to 6. You could put either one in for the other in this scenario, and the statement is true. And we can prove that by adding 2 to both sides and getting this cancels and saying that 6 is equal to 6. Right? So we see that we've been using substitution all along. We just didn't realize that we were using substitution. Now, we were identifying it earlier with our function problems, like where we would say, if f of x is equal to x minus 1, then what is f of 2? And we would say, okay, well, 2 minus 1 equals 1. And 2 would be our substitution value for x. We would put 2 right in here for x. So, I mean, that's what we've been doing. We've been learning how to substitute for a very long time and didn't realize that we were using something called the substitution axiom. Now we're going to apply that to variables. We're going to take an opportunity to solve problems with more than one variable by relating them to the same variable on the other side of the equation. And what that's going to do is going to give us the opportunity to solve for one variable and then turn around and sub it in to solve for the other variable. So let me give you an illustration. We're going to use substitution to solve for x and y. All right, we're going to solve for x and y. And we've got two statements here. 2x minus y equals 1. And x equals negative 3y plus 11. So in order to solve for substitution, what we have to do is we have to have a value of a variable all by itself. And in this case, we have x all by itself. We know what x is equal to. So if we have that, then we can take the value of x and put it into this equation to solve for it. So we're going to rewrite this and say 2, and we're going to take the value of x, which is this right here, and put it in, because it's 2 times x, and this is what x equals, negative 3y plus 11 minus y equals 1. That is the same expression we had here. We just took this x value and put it in behind the 2. Now we're going to distribute and solve for y. So 2 times negative 3y is negative 6y. 2 times positive 11 is positive 22. Minus y equals 1, right? We can combine these two y's. Remember, this is the invisible 1 right here. So it's going to be negative 7y. And we're going to subtract 22 from both sides. So minus 22 minus 22. That's going to be negative 21. So when we divide this and this by negative 7, we find that y is equal to 3. Now that we know what y is, we can put y up here. Y is equal to 3. Now we can bring it in and solve for what x is. So if x is equal to negative 3y plus 11, then I could say that y is 3. So negative 3 times 3 plus 11, that's negative 9 plus 11. Then x is equal to 2. So I can put 2. This is how you would solve an x and y. This is how you would give me the answer in the system. You're going to give me an ordered pair. So you can see that later on, these are going to be linear equations. Right now, we're just learning how to write the answer correctly. And yes, this is a point on the Cartesian coordinate system. But we are learning how to solve for one variable using a substitution method. You remember just a couple of lessons back, we learned how to solve for a particular variable. Let's say we would have a over b equals c over d, and we would say solve for c, and we would solve for c, and we'd find out that c equals, some combination of a, b, and d, right? So that's what we're doing now. We are solving for a particular variable first, and then we're using whatever it equals to sub into another equation, but they have to be within the same system. All right, so this was 54.1. So let's do 54.2. All right, in 54.2, all right, we have a system we're going to use to solve. We're going to solve for x and y. So we have 2x plus 3y equals negative 13. And we have that y is equal to x minus 6. So we know what y equals. It equals this right here. So let's go ahead and take this and put this in for y. 2x plus 3 times the value of y, which is x minus 6, equals negative 13. Now we distribute 2x plus 3x minus 18 equals negative 13. We combine these two, we get 5x. We add 18 to both sides, and we get 5. X is equal to 1. Now we come back up here and we say if y is equal to x minus 6, then it is equal to 1 minus 6, which means it is equal to negative 5. So our ordered pair that we would answer, our answer would be that x is 1 and y is equal to negative 5. Okay? That is how we would give the answer, and this is how you would type it into JupyterEd. All right, let's try one more, and then I'll let you guys do one of your own. 54.3, we have 3x plus 2y is equal to 3. And then we have, I'm going to write it over here so it's easier. X is equal to 3y minus 10. All right, so I'm going to sub x in. This is my value for x. So I'm going to say 3 times 3y minus 10 plus 2y equals 3. That's 9y minus 30 plus 2y equals 3. Now I can combine these and get 11y, and then I can add 30 to both sides. That gives me 33. Y is equal to 3. Okay, I divided 33 by 11. That gave me 3. So if y is equal to 3, my answer, I have a 3 in the y spot. Now I've got to find the x. So now I just take my y is equal to 3 and I put it in up here. 3 times 3 minus 10, 9 minus 10, negative 1. So x is negative 1. See how easy that is? You guys can do this. I have every faith. Let's clear this page. 54.4. I would like for you all to solve this one if you can. We're going to solve for x and y. We have negative x minus 2y equals 4, and y is equal to negative 3x plus 8. All right, so I want you to pause the video, solve for both, give me the answer in the ordered pair, and then press play and see if you got the ordered pair correct. All right, go ahead and pause now. All right, so here is what you should have gotten. You should have gotten x is 4, y is negative 4. If you got 4 and negative 4, then good job. That is the correct answer. If you did not, then let's walk through it. So we were given that y was equal to negative 3x plus 8. So we subbed that in for the y that's sitting in here, right there. And then we did the distribution. So we brought down our negative x. Negative 2 times negative 3x is a positive 6x. Negative 2 times a positive 8 is a negative 16. Right? So we combine negative x, remember that's a negative 1x, plus 6, that would give us a 5x. And then we added 16 to both sides, which gave us a 20. So 5x was equal to 20. We divided both sides by 5. That gave us that x is equal to 4. So we came over here to our value for y, and we put 4 in for x. We said negative 3 times 4 is negative 12, plus 8 is negative 4. So y was equal to negative 4. So we wrote 4 for x and negative 4 for y inside the parenthesis, and that is how we would answer. If that is what you got, then good job. We have one more we'll do together. 54.5. And in this one, we have 2x plus 3y equals 5. And we are told that x is equal to y. So it does not matter which one we solve for, does it? No. I'm going to say that x is y, and I'm going to put 2y plus 3y equals 5. 5y equals 5. Divide both sides by 5. Y is equal to 1. Well, if y is equal to 1, then x is equal to 1 because they are the same. So my ordered pair would be 1 and 1. And that would be the answer to that one. All right, so I hope that you understand what we're doing now and how we're doing it. If you have any questions, please let me know. And I will see you in lesson 55.